Hello everyone, now we will start 4.3 dividing polynomials. So this chapter we will try to divide two polynomials. If I divide px polynomial with qx, there will be some remainder. Some remainder will be there and then it's a quotient and then dividend. So it's a mixed fraction form of two polynomials when they divide. First method we will learn that's known as a long division method. Long division method. In the long division, we will try to write in this way as we generally do the division. Here the term 2x power 4 plus 3x power 3 plus 5x minus 1. And this term is x square plus 3x plus 2. Now let's see the first term. First term is x square here and here it's x power 4. I have to multiply something with x square so it becomes 2x power 4. So first it's multiplied by 2 and now I have to make x power 4. 2 is already there, power 2 is there. I need 2 more powers. So 2x power 2. This term multiply with this. It will be 2x power 4. Then this term multiply here 6x cube. Now next 2 2s are 4x square. Now after this you have to change the signs. This will change to negative, this positive will change to negative, this positive change to negative. Positive x power 4, positive 2x power 4, negative 2x power 4, cancel. 3 minus 6 is minus 3x power 3. There is a no x square term, so leave it x square as it is because I cannot add or divide with this term anything else. So this term as it is. Anything else? No. So keep these two terms as it is because this is not used in this step. Next, I will multiply the next term with power x. So x power 2 is multiplied by x because I need negative 3. So I multiply by negative 3x. And it becomes negative 3x cube. Then 3 3s are 9x square. 2 into minus 3 minus 6x. Change the signs. This negative become positive. This negative positive. This negative become positive. This cancels. Minus 4 plus 9. It's plus 5x cube. Plus 5x plus 6x. It's plus 11x minus 1. Okay. Now you can see both have the same power now. You no need to multiply by x. Only constant will multiply. I need 5, so multiply by 5. 5 into x square. 5x square. 3 into 5. It's a 15. Then x. 5 into 2. It's 10. Change the signs. Negative, negative, negative. This cancels. It's negative 4x. It's negative 11. Now you can see the last term has a power of x less than what is the term we divide with. So here x square, but here you are getting remainder as a term with x power 1. So this is the last term. You don't have to solve after this. This is done up to this. We divide the two polynomial in this way. You got the dividend here and it says divide this. If your remainder is 0, if you got the remainder 0, this term is 0. This means this small term that you are dividing, this is a complete factor of the given polynomial. It's a complete factor. If it divide and give you the remainder 0. Okay, next. Next we are using syntactic division method. In the long division method and in the syntactic division method, the one main difference is syntactic is only used when you are dividing with x minus 3 only. Or you can say linear polynomial. You are dividing by a linear polynomial, x minus 3. So how to write? In x minus 3 equals to 0, x is 3. So try to make this shape, it's L shape like this. Now write the coefficient of the given polynomial that is going to be divided. X cube coefficient is negative 1. X square coefficient is 4. X coefficient is missing. The coefficient of x is missing. Whenever the coefficient is missing, try to use 0. Then constant term is 9. Here you will write the term x value, that's 3. Okay. The concept is leave this term down as it is, negative. Now multiply this negative 1 with 3. It's negative 3. 4 and negative 3, 1. Multiply 1 with 3. 3 ones are 3. 3 plus 0, 3. Here we are not taking negative sign. We are taking the same sign as they are. 3 3s are 9. 3 3s are 9. 9 and 9, 18. Every time when you get this last term, this is a remainder. This is a remainder. And this is a quotient. How to write a quotient? This is a constant term. This is the term contain x, and this is the term with x square. So you will say negative x square plus x plus 3. 3 times constant, right? 1 time x, negative 1 time x square. This is quotient. And the remainder is 18. 18 is remainder. Okay, done. You can write in a mixed fraction form. X square plus x plus 3. It's a negative x square. Plus remainder at the top, dividend here x minus 3. Okay. Next, divide this polynomial by this. So here I will solve by synthetic method first. X plus 1. From x plus 1, what is the value of x? X value is negative 1. So you have to keep this negative 1 here. And then we will make this shape and write the all coefficients. 3 minus 2 x here, only coefficients, right? So 2 and negative 5. You can see all the coefficients are present. X power 3, x power 2, x power 1 and constant. Leave the first term as it is down. 3 as it is down. 3 into minus 1, minus 3. Minus 3 and minus 2, minus 5. Minus 5 into minus 1, positive 5. 5 and 2, 7. 7 minus 1, minus 7. 7 into minus 1, minus 7. So minus 5 and minus 7, minus 12. This is the remainder. As you got, this is the remainder. This is a constant term with x and term with x square. So your right term in the mixed fraction is x square plus, it's 3x square minus 5x plus 7. And now remainder. Minus 12 is the remainder and the polynomial that by which you divide x plus 1. Okay. Now I'm using the same polynomial, divide with the same x plus 1 but using long division. X plus 1. 3x cube minus 2x square plus 2x minus 5. X and x cube. So I need x power 2 more. It's a coefficient 3. So x is multiplied by 3x square. It's 3x cube. 3x square multiplied by 1. It's 3x square. Now change the signs. This change to negative, this change to negative. We change the sign only in the long division, not in the synthetic division. Not in the synthetic division. Okay? Okay. So this got cancelled. So you left with negative 5x square. Okay. These two terms are not used. Write it down as it is. 2x minus 5. Now x and negative 5x square. So I will multiply by negative 5x. Negative 5x multiplied by x. Negative 5x square. Negative 5x square. Negative 5x into 1. Negative 5. Then change the signs. It's cancelled. 7x minus. Now only use the 7. It's a 7x plus 7. Change the sign. It's a cancel. And you got negative 12 only. Done. You can also see this is the quotient, this is the remainder, and this is the remainder. Okay. Either you use which method, you will get the same answer. But remainder, you can say that syntactic division is only used when you are dividing by a linear polynomial. Only like x minus 1, x plus 1, x minus 7, x plus 7, x plus a type or x minus a type. If you have an x square on divide, you will use long division, not syntactic will be used. Next is the remainder theorem. Remainder theorem means you are dividing the two polynomials, you are getting remainder. So what will be the direct remainder if you only want remainder, not any quotient, you don't want that quotient, just remainder. It says if px is a polynomial divides with x minus a, and make sure the remainder theorem is only used with a linear polynomial when you are divide with a linear polynomial. Okay, divide with x minus a, then remainder is equals to polynomial at a, polynomial at value a, that will be the remainder. Okay, let's try this. It says use syntactic division to evaluate this function when x is negative 4. So when x is negative 4, syntactic division means they are substituting this term, negative 4. X is negative 4 here, 5 minus 1, 13, 29. 5 as it is down, 5 into minus 4, minus 20, minus 21. It's 84. Okay, so you will get 97. Then multiply with this, negative 388. And if you subtract, and if I try to substitute negative 4 directly in this function, it's f of negative 4 is 5, negative 4 power 3, negative of negative 4 power 2, plus 13 times negative 4 plus 29. Once you calculate, you will get negative 359. So remainder will be same. Either you directly substitute or you use syntactic division. Always the last number is the remainder. Okay, so this was 4.3. Here you can also check. We divide here remainder. We got remainder 18. If I use remainder theorem, minus 3 because x value is 3 here, minus outside 3 cube plus 4, 3 square plus 9. 3 cube is 27, outside negative, so negative 27 plus 3 3s are 9, 4s are 36 plus 9 which is 45 plus negative 27 which is 18. So you are getting the same remainder. Okay, so today we learn long division, syntactic division and remainder theorem. I hope you understand. And thanks for watching. We will continue in the next video.